Hi, welcome to the primer of the Rapid SDK add-on for Blender, which makes curve-based driver setups very easy. To make it quick for the people who don't want to spend too much time with lengthy explanations, here's how it works in general. Though, since this is one-button workflow, there are a couple of things you need to consider in order to avoid any dead ends. And for this, I will go into more detail after this rough introduction. So, let's get started. To create a driving relationship, you need to define a driver and driven object up front by selecting it. The active object is the driver, and since there only can be one object active, it's limited to that. For the driven, you can have either one or multiple objects selected. Driver and driven should be in a state which defines the starting point of the relationship. Now, from Object Animation, choose Rapid SDK. This initiates the tool. In the 3D view, you can see more info about what's part of the setup. Adjust the properties of the driver and driven. Transforms, custom properties, and shape keys are usually the ones of interest. When you're finished, run Rapid SDK again. You can also use the F3 search menu for quick access. And that's it. The changed driver properties drive the changed driven properties. If you want to edit the relationship in a nonlinear way, go to an in-between state and run Rapid SDK to enter edit mode. Now you can change the already driven properties. When you're finished, run Rapid SDK again. Okay, this about wraps up the short overview. But as I said earlier, there's some more things to consider, and if you're new to using drivers like this, you might want to stay a little longer. So let's start from the beginning. SDK stands for Set-Driven Key and is a phrase most Maya users are familiar with. It basically describes a technique where a driving value drives a driven property through a function or animation curve, and every particular value relationship is defined through a curve key. Even though in this case the driving value is not the time, but the property of the driver. The advantage of creating control setups this way is that it's computationally cheap, because nothing really needs to be calculated. Plus, it gives the user control about how one value drives the other. You can even add intermediate keyframes to further refine how the input value affects the output value. In Blender, you have this function curve available every time you create a new driver, but it's quietly sitting in the background, and most people don't seem to be aware of it. Just because it's more obvious to use a simple expression to define the relationship. And there's nothing wrong with that. It's just that this curve can give you quite some more control. Unfortunately, the general downside is that in order for the curve to work properly, values need to be edited, and then there's a lot of back and forth to get it all working as expected. And of course, this isn't fun. This is where Rapid SDK comes into play, creating and editing of driver curve-based relationships with only one button. There's no need to define driving and driven properties up front, only the object selection counts. The tool simply compares which properties have changed and sets up a driver for these. Of course, this can raise issues when you want to create a driver when everything else is already moving or animated. This is not what Rapid SDK is made for, and it clearly has limitations due to the one-button workflow. But that doesn't matter, just because it's made for the 80% or more of all cases where you quickly want to set up a driver and don't want to deal with all the little tweaks. The basic workflow for setting up a driver is usually that you define a pose as the start of the range and then a pose at the end of the range. The majority of all drivers works like that, and most of them are fairly simple. Drive a door, a piston, rotate a bone, scale a muscle, drive a shape key, you name it. Then once in a while, there's need for some nonlinear interpolation, and that's when additional keys get added to the curve. Or you tweak the curve manually, that's up to you. And usually you set up drivers before everything is moving, and this makes it easy to identify what's changing. Let's take a look at another example. Here I have a robotic arm, and its cables need to move according to the arm's motion. The cable splines are made from multiple points, and this makes it a bit harder to rig in order to make them move correctly. Each point is hooked to a bone of the armature, which in return is parented to one of the articulating bones. The task now is to tell each hook bone to move in a particular way when an arm bone rotates. For setups like this, it's come to create a temporary range of motion animation, or simply ROM, which articulates each moving element to their extremes. In this case, how far one element of the robot can rotate forward and backward. And it should be the extremes to make sure that it works for every in-between position during the animation. Since in this example all participating elements are bones, I switch to pose mode, which makes selection easier. I make sure that I'm at the default pose, which is the resting pose. From here, the arm rotates forward and backward. I select all the hook bones, which should be moving when the arm rotates down, and then the driving bone last. This is the active object, which defines it as the driver. Note that my driving bone is on a hidden layer. Rapid SDK accounts for this and makes selecting easier. The right selection is crucial, especially when working with bones. With the selection in place, it's time to run Rapid SDK. For faster access, you can also use the F3 search or add it as a quick favorite. Now I'm in Create mode, as the label on top of the screen indicates. You can also see at the bottom left which selected objects are driver and driven. If for any reason you need to exit the driver creation, simply run Rapid SDK again. This will cleanly exit the tool. Since I'm now in Create mode, I already defined the starting point of the driver. Next is setting up the end point of the range. First, I'm going to the extreme pose of my driver. Because I have keyframes set for the poses, this is easy. You first define the driver's endpoint and then set the driven state. Because the tool watches for changed properties, keep in mind what you want to change. In my case, all hook bones need to move in Y and Z. I estimate where they need to be and move on to the next. If a position doesn't work out, I can always edit it later. Once I'm finished, I run the Rapid SDK operator and create the drivers for everything that changed. Let's check the result in the drivers editor. By default, the resulting curve is linear, which usually is what we want for almost all sorts of relationships. Any easing for the resulting animation should come from the driving object, but not from the driver curve. Okay, now it's time to verify the result and how everything is moving. By moving the time slider and going through the range of motion, I can check if the driven hook bones are moving correctly. If there's anything to adjust, it's not a problem. One limitation of the one-button workflow is that editing can only be performed with one object. A selection with only one object always means edit mode. For now, I only want to edit the endpoint of the relationship. Therefore, I make sure that I am at the keyframed extreme of my driver. I select one object to adjust and again run the Rapid SDK operator. This puts the object in edit mode and checks which property is valid. Edit mode is also indicated at the top of the screen. For edit mode to work, the current drivers are muted. Otherwise, I won't be able to adjust the properties. I adjust the position of the driven hook bone, and once I'm done, I run Rapid SDK again, and the end key of the driver gets updated. This process I repeat until everything moves as expected. As I mentioned before, most driven relationships are simply defined by a start and end point. Only sometimes it's necessary to add one or more in-between states. Like in this case, where the rotation of the robot's arm drags the cables into one direction and then slightly pushes them back again. Therefore, I need an in-between state. I drag my time slider to the frame where I want the cable position to have an extreme. Again, I select one object at a time, run the operator, adjust the position, and run the operator again to add a key. Done. Checking the driver curve shows that this new in-between key is smoothly interpolating. Usually this makes most sense, but it's also possible that some other interpolation is needed by default. And this can be changed through the add-on's preferences. Here you can see that we have a different handle type for the enclosing start and end keys and any intermediate keys. There's also an option to have extrapolation on by default for the generated curves, which sometimes makes sense to have an infinite relationship. And of course settings for the position of the main mode message and its color. The value tolerance setting defines how large a value change needs to be in order to be recorded. Now about how it's possible to add new properties to the relationship, maybe because something has been forgotten during the first pass. This is mainly done by simply creating a new driver. In my case, I want to rotate one of the hook bones to better control the cables. I select the hook bone and then the rotating arm bone and run the operator. Of course, making sure I'm at the rest position of the driver. Driving properties which are not animated or driven is always possible. Only when these are animated or driven, creating a new driver is prohibited. The rest is editing the driven at the driver's extreme position and running the operator again. And that's basically it. As a last example, let's take a look at driving key shapes and using drivers in a character rig. In my scene, I have a simple arm, nothing special, with some basic animation and deformation. The mesh already has 2 shape keys ready to use, one to fix the elbow deformation and one for the wrist. As they are meant as correctives, they only should get triggered when the related bones rotate. The shape keys are located on the mesh, but when working with bones, we need to be in pose mode. So there's a lot of switching between modes up ahead. To avoid that, you can go to Edit and disable Log Edit modes. This would make it easier to switch modes when the selection changes. But this is not necessary, since the selection detection of RapidSDK works independent from the mode. You can be in object mode and still use selected bones from the armature. Let's start with the wrist corrective first. To be able to select the correct bone, I expand the hierarchy of the armature, select the mesh first, and then the bone, which should be the driver, in this case the wrist bone. Now, here's something to look out for. When selecting bones this way, don't get distracted by the highlighting of the bone name, but which icon is active. This indicates the right bone. There can even be cases when 2 bone icons are active. Then you need to deselect the ones you don't need. Only one icon is supposed to be active. And this is only true when you're in object mode with the armature. With the selection in place, run the operator. Of course, I'm at the rest pose, and checking the right object names for the driver and driven is always a good practice. Then moving to the end pose. In my case, this is 2 frames past the point where the arm is bent most. Of course, this isn't really an extreme, but this is for demonstration only. Now, I select my mesh, go to the mesh properties and turn the wrist corrective on. Running the operator leaves create mode and sets up the driver. The same with the corrective of the elbow. This time it's the mesh and the lower arm bone. Start pose is the rest pose as usual. With the arm in the bent position and setting the arm bend corrective to 1, I can leave create mode. As a final touch, it's easy to refine the deformation with the use of helper bones to mimic bones or muscles. One is for the elbow, meant to give the elbow a bit more of the pointy shape to counter the volume loss of smooth skinning. The other one is meant as a substitute for a biceps muscle to give some bulging effect when the arm bends. I start with the elbow bone. Since there's no mesh selection required, I work in pose mode. I select the elbow bone and then the low arm bone at the rest position and run the operator. Now I move the elbow bone a little out along its axis and also introduce some scaling to create a more pointy shape until it looks good. Leaving create mode and the work is done. On to the biceps, same procedure, default pose. I select the biceps bone and then the low arm bone, enter create mode and adjust the biceps bone. A little moving and maybe scaling. After being finished with the adjustment, it's time to leave create mode and be done with it. And at this point, it's really starting to be a fun ride to add all these little extra details. Lastly, I want to show how easily the driver curves can be manipulated to change and fine-tune the overall result. Like with this bicep deformation. Maybe the bulge should not happen in a linear way, but start slow at first and then push more towards the end. Selecting the bicep bone shows the driver curves in the driver's editor. Here we can see that the curves are currently interpolating in a linear way. Now, adjusting the linearity through the add-on is a bit more work this time, because I changed multiple properties, so it's easier to do that through the editor. I set my cursor to a point a little ahead of the center of the interpolation and add a key for the selected channels. Next, I turn off snapping through the header menu, because when moving keys, I don't want any snapping to happen. I select the newly created keys and move them a bit away from the original position towards the end pose. This makes it slow at first and faster towards the end. And that's it. Congratulations, you just about mastered the secrets of creating fast and easy driver curves and maybe even learned 1 or 2 tricks along the way. So, thanks for watching and happy animating.